All right. Good afternoon, everyone. I'm pleased to be here talking about something obviously I have a passion for, which is irrigation. One of the biggest things from our perspective is water savings as a selling point. Um, there's a lot of different ways to water your grass and a lot of different grades of components and methods for installing an irrigation system. And we're pretty committed to the idea of saving water as a key to what we deliver to the customer. The easiest way to think about it is typical irrigation system has a life of 15, 20 plus years. And the upfront cost of installing all the components and putting the system in the ground, that's a one-time cost. Your ongoing cost, obviously, is the water. Think of it as the fuel in your car, and that's the one thing you can control. And we do try to talk to customers about total cost of ownership. So perhaps we're not the lowest price guy in town when we come out and talk to you about irrigation, but we make the argument that over time, because of the designs we have and the components we use, you're going to have a better total cost ownership over the life of the system. So on the first slide here, I want to talk a little bit about design basics and what really a good system design is. Like a lot of things, you know, good design's not complicated, uh, but people, through wanting to save money on components, perhaps not even thinking stuff through, uh, you can create a system that really doesn't work very efficiently. And we see that in the marketplace. A lot of times we're called in to remediate work that wasn't done thoughtfully, and just some basic principles in irrigation. So the first thing is head-to-head coverage. And so what that means is anytime you design a system, you design it where there are two heads spraying at each other. And the idea is, I always use a golf rotor as the easiest example. We've all seen, the long stream of water coming out on an athletic field or a golf course. So closest to the head, obviously, it's a pretty narrow spray of water. Then as it goes out over many feet, it begins to dissipate. And so what you get is sort of a falling off of that water. And so what we do in a good design is you have two heads pointed at each other in effect, and their pattern of where it's tight and where it's beginning to disperse match each other, yin and yang, if you will. And that gives you complete and full coverage. Now, why that matters is if you don't do this accurately, you don't do this thoughtfully, what you're going to end up doing is you won't get good coverage. And the easiest way a customer will try to fix that is they'll run the system more and they'll just keep trying to put more water down because it's really not keeping everything green. An example is these most of these heads, so the rotors, the ones that throw the water a long distance, they're designed to throw a maximum of about 35 feet. Uh, we actually space them between 20 and 25 feet. That way they're adjustable. You make sure you got the appropriate amount of overlap. And in our climate, the fact is you have to deal with wind, and wind obviously will impact how far the water is going to go. So if you put them out there at their uh, maximum distance, you're going to have problems with coverage. And back to the not being the cheapest guy in town, if you're trying to save money and present to a customer, hey, I can do this system for you $500 cheaper than the other guy, those are some of the things you'll do. You'll eliminate a head here or there. You'll space them at 30 feet instead of 20. Just little things like that. So good design, like I said, it's not hard, but it's also a place where if you're or somebody that just wants to hit and run with a customer, sell it to them one time and not take care of it. You know, there are ways to do that. And unfortunately, there are contractors in this market that will take that approach to things. The bigger guys here in town, us included, I would argue my best competitors do it mostly the same way we do. We really focus on trying to make sure you get an efficient system. The other thing you have to keep in mind, that concept of a microclimate, it's really just if you think about a house sitting on a lot, there's one side of the house that most likely has got shade in the afternoon and maybe sun in the morning. You might have a slope more pronounced in your backyard than you do in your front yard. Those are all things that matter in terms of how you want to put the water down. So you don't combine heads in an area where you'll have full sun in part of it and you'll have shade in part of it. So you've got to break up and make it easy for the customer to set the times and set the frequency for the microclimate or that little section of the yard where it might be different than the front, the side, the back. All things that don't sound that complicated, but if you're just out there slamming stuff in, it's easy to combine things and suddenly you realize, gee, I got my driveway's radiating all this heat in the summer and it's burning up this part of the side, and that part also connects to the part that's shaded by the house. And so I'm either making a swamp out of the side of the house or I'm burning up near the driveway. So minor things, but stuff that's really important to keep in mind. Again, things like a smart controller, rain and flow sensors, those are things that you can eliminate cost on the front side. Costs a little more to put in Wi-Fi connected controllers. It costs more to put in rain sensors, flow sensors, things like that. But in the end, a smart controller has the ability to adjust the weather patterns for you automatically, and you don't have to manage it yourself. Same way a rain sensor, it's a $100 item, but in the end, it'll save you that money over the life of its product life, because it'll shut your system off when it's going to rain and when it's raining. And nothing's sort of more comical than driving by and pouring down rain and you see a irrigation system running. Pressure regulated heads. The basic rule of thumb with a head for irrigation is they're all designed to operate optimally at 45 psi. And what that means is anything above that or below that, it's not going to meet its need to, carry the water 10 feet or 20 feet or whatever that particular component's designed for. But more importantly, and it's certainly in this marketplace, there's a lot of higher PSI water delivery systems here. Urbandale be a good example. Johnston, Waukee, they're all out there. Inbound pressure to the irrigation is 80 PSI. And so what happens with that is if you don't use the pressure regulated heads, and what that means is they have a piece inside of them that takes this pressure down to 45 PSI before it hits the head for distribution. If you don't do that, I use the hose analogy, which is if you had a garden hose and you just let it run, it's going to come out with a certain amount of flow. It'll be a nice stream of water. You put your thumb over it, suddenly it's dispersing, it's atomizing, and it's wasting water at the end of the day. And so the pressure regulated heads, they cost twice as much as the ones that aren't. So again, if you're trying to deliver a system that's cheap, that'd be a thing you'd skip. And customer doesn't know the difference up front. They might not know the difference over time, but they'll use a lot more water because of it. Now, one thing that, like many things in the world, the West Coast, California, Nevada, Arizona, where water has become extremely scarce, they're driving the basic component updates. And so, for instance, in California, you can't install anything but a pressure regulated head. And those markets out there are big enough that they're going to drive the manufacturers to the point where that's all they're going to make. And so that will be a very good thing for those of us that are in less of a water crisis than they are in the West. And it will drive things like smart controllers and all these different sensors will be mandatory just because, irrigation is a luxury. It always will be, no matter what part of the country you're in. So because of that, it makes sense to regulate it. And then drip irrigation, rotors, and sprays. So the easiest way to think of this is each one of these has a different level of efficiency. So a drip line, so that's the tubing that lays on the ground, has an emitter or basically just a hole in the hose uh, every 12 to 18 inches, depending on the spec of the drip line. Typically, it's covered in rock or it's covered in mulch, something, but that drip irrigation's on the ground and it's considered to be 90% efficient, meaning you lose very little water to evaporation just because it's coming right out of the tube onto the ground. Rotors, the heads that we use to do the larger bits of turf, the ones I was saying that will space at 20, 25 feet, those are about 75% efficient. Again, meaning that as that water leaves the head, it's subject to evaporation loss, either from the wind, from the temperature. You're just not going to, 100% of what leaves that head isn't going to end up soaking into the ground. And lastly, the spray heads. So you'll see those along, let's say, a parkway, side yard, more narrow areas. They're used for areas that are about roughly 10 to 15 feet wide. Those are the least efficient. About 60% of the water that comes out of those ends up soaking into the ground. And the reason for that is they're designed with heads that, because it's in a tighter space, it disperses the water in a more atomized pattern, which by nature is more subject to evaporative loss. So drip irrigation is a great solution in terms of efficiency, but it's a great solution where you have a very static landscape you're trying to water. And so what you'll see is commercial projects, uh, because they'll go in with one basic landscape. They're not going to dig up stuff every year and replant something different. Drip irrigation is great. And you can put it down. The plants are going to be there. A good designer on the landscape side will make sure that within a drip area that all the plants need the same amount of water. Because the one negative on drip is as you put together this area, it's all going to get, everything in that area is going to get the same amount of water. So, you can't have plants that don't need much water matched up with plants that need more. And because it's very difficult to control that in drip. The reason we don't generally install a lot of drip with residential homeowners is most people that are, looking for irrigation in their plant beds and different landscape areas tend to be gardeners and people that are passionate about it. And quite frankly, they're digging up, changing things out every year. And that drip, when you put it down, if they're changing the plants, moving stuff around, you're going to have to go out, pull it up, and relay it out for the new pattern of the plants that are there. So generally speaking, we don't use a lot of that drip in a residential environment. So all this design stuff, it's pretty simple, pretty easy to do, but a lot of ways to cheat. So let's talk a little bit about water math and how to program a system. I don't think it's any secret clay soils here, especially in Des Moines Metro. And so that limits how much water you can put down. Um, Generally speaking, again, slopes matter. There's always going to be differences in soil from even property to property. But basically, you can put down somewhere between a tenth of an inch to 20 tenths of water per hour. And if you put it down that rate, it won't run off. Um, Here's where it gets complicated. So in July, August, the grass takes away more than that. And the whole uh, calculation we talk about is evapotranspiration. So it's really just a combination of, is it sunny or cloudy? Is it windy or still? Is it humid or not? What's the temperature? And all those things come together to drive how much moisture that turf's going to take away. So the question becomes, okay, in July, August, what do I do? The grass on it typically would be taking away more water than I can put down without runoff. So now what? Well, start with the idea that the typical system is putting down about between 10 and 15 gallons, on average, 13 gallons of water per minute. And it's going to do that at about 65% efficiency. As I was talking earlier, it's the mix of heads kind of works out that way. So what you put, you're putting that 13 gallons out there, but really 65% of it's what's going to soak in. Pretty common run times for most zones is 15 to 20 minutes. And why is that? A 15-minute run time with that many gallons going down per minute will get you really close to saturation. And if you run it any longer than that, you're basically just running the water off. And again, the question becomes, okay, so if I can only run it 20 minutes and I can only get this much water down before it starts running off, what do I do? And the next slide, really, we talk a little bit about, well, what are your options, right? You can add days, essentially just say, I'm going to add frequency uh, and allow that to help the turf catch up. Again, there's, we call it cycle and soak. And it's really, it's a feature of most modern controllers. And what it does is it'll run, let's just say, 20 minutes on that zone, and then it'll put it back in the queue for later. And as that whole system runs over the course of a couple hours, it'll suddenly cycle itself back around and run that same zone again. And by the time you've done the cycle and soak, you've now managed to close the deficit on the amount of water that the turf needs. The other one that is a little more interesting, and we try to use this when we're putting new landscape in, typically on a commercial project or someplace where they're putting new sod down, the syringing. And really all that is, generally speaking, you run irrigation overnight. And you run it overnight because those are the stillest hours, the least amount of wind typically. And so you don't run in the middle of the afternoon when it's hot, the wind's blowing. But one thing you can do, and it's essentially like just think of it as like if you were ever in Arizona, California, where they use the misters out on a patio. You can cool down the environment by just doing a quick, couple minute run of a zone, puts a little water down, takes some of the stress mid afternoon off of the turf. And while it's inefficient in terms of how it uses the water, it is efficient in terms of trying to keep the sod alive. So there's a lot of different ways to go about this. Generally we'll work either with a homeowner or a commercial property owner, and we'll look for these optimization points. And, sometimes it's a matter of just running twice a day and running cycle and soak. So there are what I would call friendly technologies that are built into the most modern of the controllers, and the one we try to push people to use are the automatic adjustments that are built into the most current controllers. Doesn't matter if it's a Hunter or a Rainbird or Toro; they all have these features in them. And what they do is, amazingly enough, to me at least, there are literally hundreds of weather stations in this area. Almost anywhere you go in the state of Iowa, there's a network of weather stations that just average Joe homeowner has put on his weather station onto the internet, and you can source that information through these controllers. And so what it does is it knows forecast, it knows what's coming up, it knows what's going on around it, and it can make adjustments accordingly to either add time to the run times, take time away from the run times. And then you have all these parameters. Examples are here on the slide. Don't water when certain temperatures exist, or the forecast is saying I want this is going to happen, it's likely to rain, whatever it may be. Wind speed's really the probably, if you picked anything, probably the biggest thing. Wind in a windy day pretty much makes it close to impossible to do a good job of watering the turf. So innovation in this. This is a pretty cool product. I will tell you, it's at a very slow adoption rate. We've worked with two customers on this. It's pretty remarkable. So it's a guy. He was an inventor. Really saw how imprecise you can be with irrigation. And the fact of the matter is, you always want some overlap. If you're watering along a sidewalk or driveway, you'll adjust it, but you're still going to put some of it on the concrete, because if you don't, it's not going to take it all the way up to the edge of the turf. So he saw this opportunity to try and apply water like it was a laser printer, extremely precise, uh, completely adjustable. Every stream that's coming out of this head has adjustability all the way through its complete pattern. It's really remarkable. It's also really expensive, and that's been there's really two things that have made this tough to sell to a customer. It costs at least twice as much as putting in a conventional system, but more importantly, we don't really know the lifespan of these components. Generally speaking, the stuff we install, the everyday Rainbird, Hunter, Toro type components, typically have at least 10-year lifespans on them, in many cases 15 to 20. And when it comes time to replace them, not particularly expensive. Irrigreen, they're really not guaranteeing long lifespans at this point, and it hasn't been available and installed long enough to have a real handle on that. And so we've been pretty cautious about trying to go forward, because something that we can replace today that costs, say, $20, the similar Irrigreen component is more like $250 or $300. And so if they last half as long, they cost 10 times as much. You know, it's hard to feel good about selling a customer something like that. Incredibly efficient, really innovative. It's just one of those things that we're just going to have to wait and see, because the maintenance and the total cost of ownership over time is an important thing. And while you can save some water if you're constantly replacing extremely expensive components, then you probably haven't saved much. So basic ideas for saving on water. So I mentioned the high efficiency rotors and sprays, and there's tons of university studies around that have proven that if you use these pressure regulated heads, the savings there, the difference in the cost is well outweighed. We generally tell people that you get the payback on the extra expense within the first year that you own the system. It's always hard to be real specific about that because, of course, you don't know what the weather's going to be like. You don't know how much it's going to get used in a particular year. So, you can't really, narrow it down looking forward. But in an average year, with average weather, you'll see a payback on this investment within a year. And then basically you have the water savings from that going forward for the life of the system. As I mentioned, there's a lot of standards that are getting driven by California in particular. The good news is the bigger contractors here in the Midwest, ourselves included, we were already on these standards and we were already designing and delivering systems that meet these standards. One thing I would be cautious or urge you to be cautious with is understanding that there are different grades. There's professional grade product, contractor grade, whatever you want to call it, versus the stuff you can go and buy at Home Depot or buy at Menards. They're vastly different products with very different quality of build. They might say Rainbird on the box for both products, but they're in no way similar products. So anytime we talk to a homeowner and he says, "Oh, I'll just go fix this myself. It's not that hard. I can dig a hole in the ground." True enough, but we try to encourage them to use the same suppliers we do. The local wholesale guys here in town, Site One, Reams, MTI, they'll all sell to average consumer over the counter, and they'll give you the better of the components and the kind of stuff that if you do try to do something yourself, at least it'll match the other product that you have there and will work in a similar way. The last piece is the rain, soil, and flow sensors. And just to take a moment on that, so uh, rain sensors pretty simple. It has a little, believe it or not, it's a piece of cork inside of it. So as it rains, the cork absorbs water and it closes the circuit. To this day, I'm still amazed that is the technology. Cork absorbing water, but it works. It's worked for a long time, and they all work the same. So the idea is at a certain point of water being applied, and that cork soaks it up, shuts the system off. And then generally, most of these are programmed so it also has a delay on the backside. So just because it stopped raining doesn't mean you should start, watering right away. So most of them have a 36-hour or a 48-hour delay on the backside. So it says once this is returned to a normal state for this sensor, skip a cycle if one is scheduled right after that. And that's just really recognizing that there's already water in the ground. Soil sensors sound like a good idea, but it's a little more of a challenge here in the state of Iowa because, as I was mentioning, the microclimates make things fairly complex in terms of trying to use a soil sensor to measure the moisture in the soil and control your irrigation with that. Plenty of experiments have been run around this. It's just it's hard with our soils to make these effective. The other thing I would throw out, and this has been something we really press on with our biggest properties, people that have multiple 10, 20 acre properties, is to have these flow sensors. And what a flow sensor does, essentially, you learn in consumption with a flow sensor. So it's talking to the controller, and so basically what it's doing is it's looking for outliers in terms of consumption. So if the system's off and there's water moving, obviously you know that's not right. And so flow sensor is wired back into what's called a master valve, and just think of it as a shut off that's back at the point of connection. And so if you've got a broken component down the line somewhere, somebody hit a pipe and now you've got, water just gushing from it, the flow sensor can see that that is happening and shut the system down and shut off the water flow. Like, and additionally, uh, as it learns in, and what I mean by that is, so zone 10 in this particular system, every time it runs for 15 minutes, it uses 4,000 gallons of water. If suddenly when it's running, it uses 6,000 gallons of water, that is a way that'll tell the controller, hey, we've got a unusual consumption going on here. There's probably a leak somewhere in that zone. And as it's wired back to these smart controllers, actually you can get, especially with the more sophisticated commercial controllers, you're set up with alerts. It'll send you a text, it'll send you an email, it'll let you know there's something unusual going on out there and that you need to look at it and do something before it gets out of hand. So we're a big fan of flow sensors. You see, it's a little less common in a residential environment, just because the customer generally can see what's going on in their own yard versus an HOA where you've got a lot of space, a lot of acreage, that it's not quite as simple to have eyes on everything that's going on. So in terms of auditing a system, it's really, again, not super complicated. We tell people, first start with, if the system's off, make sure the irrigation meter's not moving. Not hard to do. Write down the reading on it. Come back an hour later as it moves. If it has, then you got a leak somewhere, and that's give us a call and figure it out. Backflows, generally speaking, in this marketplace, 85 to 90% of them are outside the home. And so if that backflow is leaking, and it's a pretty common point of potential leaks in an irrigation system, just look around, see if it's dripping, see if the ground's soft around that. Generally speaking, a backflow to some degree by design is there to leak water. Obviously, it dumps water in the condition that triggers the reliefs and pressure valves, but those are also the things that kind of wear out over time. And so you can get a leak in a backflow just from, a seal getting old and not sealing properly. And then after watering, just walk around the yard. It's really not that complicated. You're looking for soft spots. Obviously, trees are a big deal. Trees seek water, and I'm sure everybody on this knows it from administration of water mains and sewers and things like that. But the I don't know how the root smells the pipe with the water, but it knows where to go find it. And some of the more established neighborhoods in the city of Des Moines, parts of West Des Moines, for instance, where you've got a more substantial amount of trees in a yard, that's where you really do run into the trees getting into these lines, creating leaks, and pretty easy to spot them, but you just have to walk around. Most controllers, they have a test setting, so you can just go and say, hey, run every zone for 2 minutes. Just walk around and look and say, okay, do I have any geysers here? Do I have stuff that's not really throwing the water the way it's supposed to? I'm a big fan of just relying on the eyes, right? I mean, the turf will tell you if it's stressed, if it needs something, something's got to change. So oftentimes we find that if you've got a coverage problem, it's almost certainly more likely we can affect improvement with that on adjustments. And the components that we use in irrigation all have variable nozzles and adjustments that can be made to them. So you might have a nozzle that's designed to throw 10 feet, but somehow you're having problems with the coverage. You can change that to a 12-foot nozzle or a 15-foot nozzle. There's always different kinds of adjustments that are available. And, again, for a homeowner, thinking about your microclimates is just really important. That side yard that's shaded in the afternoon might need half as much runtime as other parts of your system. And if you just use your rule of thumb, like, okay, well, I'm going to do 10 minutes on all these, I'm going to do 20 minutes on all those, you're going to do yourself a disservice in terms of how you put the water down and how you use it. So that really is the core of what I had to talk about. So at this point, Cassie, I guess if there are questions, I'll be happy to take them.
Thank you so much, Dave. If anyone has questions, please feel free to put them in the chat and I will relay them. So far, we don't have any, so we'll give them a minute and see if we get any. Once again, this will be recorded too, so that you can watch it again or share it with others. All right. Well, not seeing any questions. So thanks again, Dave, for your presentation, and thanks to
Yeah,
everyone who logged in today. And if you can't find the recording on the Rain Campaign YouTube, just email me and I'll be happy to send that directly over to you. So everyone, have a great rest of your day.
thank you.